Imagine raising, you know, $7.4 billion and not to build some sleek new app or like invent a fancy algorithm.
Right, definitely not that.
Yeah, it's just to buy enough concrete copper wiring cooling systems and power grid access to keep a single piece of software from literally melting its own servers. So, welcome to today's analysis. I'm your host, and I'm here with our resident tech expert.
Great to be here. And yeah, we are looking past this massive tech headline today. DeepSeek raising that astronomical sum just to double its workforce. We want to uncover the fundamental shift happening behind the scenes here.
Exactly, because it's an unprecedented amount of capital for a company that honestly built its entire reputation on extreme frugality.
Yeah, they were kind of the penny pinchers of the AI world, or at least they were. Because we aren't just looking at another software update here. We are watching AI transition from a surprising parlor trick into heavy, dependable industrial infrastructure.
It really feels like the moment AI essentially grows up, puts on a suit, and, gets a serious corporate job.
I love that framing. It really is.
But to understand why a company so famous for being wildly efficient suddenly needs $7.4 billion, we have to look at how they challenged the biggest assumption in Silicon Valley.
Right. The idea that the only way to win in AI is through brute force. Because for the last few years, the prevailing logic was purely physical and financial. Whoever owns the largest computer clusters just wins.
Wait, let's pause there so we don't lose anyone right out of the gate.
Yeah.
When we say computing clusters or compute, what are we actually talking about on the ground?
Oh, right. So we're talking about massive warehouses just filled with tens of thousands of specialized microchips.
Like endless aisles of servers.
Exactly. All wired together, running at max capacity, and consuming enough electricity to power a small city. The standard approach was just, throw more electricity and processors at the problem until the AI gets smarter.
Just brute force it.
Yeah, brute force. But DeepSeek completely upended that. They proved that better architecture and tighter engineering can actually rival that massive spending.
Okay, but I'm struggling to picture how software architecture replaces physical servers. Like, how does that work in practice?
Okay, so think of a traditional AI model, like a giant corporation. And imagine if every single employee was forced to read every single email that comes into the company.
Oh, wow. That sounds awful.
Right. Regardless of their department. It would be thorough, sure, but agonizingly slow and ridiculously expensive. Most of your brain power is just wasted on totally irrelevant info.
Right. The marketing team doesn't need to read the IT support tickets.
Exactly. So DeepSeek uses a mechanism called selective computation.
Uh-huh.
They route the coding problems specifically to the coders and the legal problems to the lawyers. The rest of the employees stay completely idle.
I see. But how does the model actually know what to turn on and off? And I always hear the term parameters thrown around in this context. How does that fit in?
Well, a parameter is basically a tiny individual decision-making unit inside the AI. Think of it as a single brain synapse.
Okay, got it.
A large model has hundreds of billions of them. In a standard model, every single synapse fires for every single word you type.
Which is where all that electricity goes.
Exactly.
Okay.
But under selective computation, a routing mechanism looks at your prompt and activates only the few billion parameters that specialize in that specific topic. It slashes costs and massively improves speed.
That sounds incredibly efficient. But I have to ask, in Silicon Valley, secrets leak in a week. Researchers publish papers, people reverse engineer things.
Oh, absolutely.
So if you invent this brilliant architecture, how does $7.4 billion protect you from someone just copying your homework by Monday morning?
Well, it doesn't. Technical efficiency is absolutely not a permanent moat.
It's not.
No, not at all. Once a breakthrough architecture is out in the wild, competitors learn from it. It just becomes the new industry baseline. The real advantage has to move. It moves away from the brain and the model itself, and it moves to the body.
The body being the infrastructure around the model, I assume.
Exactly. Let's use an analogy. Think of a frontier AI model.
And by frontier, we mean the absolute most advanced, cutting-edge AI available right now.
Yes, the absolute state-of-the-art. So think of that frontier model as a highly advanced jet engine sitting on a test stand. It might be faster and cheaper than the engine sitting right next to it.
Okay, I'm with you.
But an airline isn't just an engine. If you want to fly passengers safely across the world every single day, you need maintenance crews, safety systems, fuel contracts, airports, customer service. DeepSeek has a brilliant jet engine. Now they are using that capital to build the entire airline.
Ah, okay. That actually explains the hiring spree.
Yeah.
When they announce they're doubling their workforce, they aren't just hiring more mad scientist researchers to tinker with algorithms.
Right. They are building the airline crew. The bottleneck in the AI race has completely shifted.
Shifted how exactly?
Well, a few years ago, the scarce asset was the researcher who could design a compelling model. Today, it's the systems engineer who can keep a massive computing cluster productive without it crashing.
Making sure the engine doesn't blow up mid-flight.
Exactly. It's the security specialist who can look a highly regulated banking customer in the eye and make them trust the system. It's the product leader who turns a chat interface into a complex workflow.
But if the giants are aggressively scooping up all these specialized systems engineers, that has to create a massive vacuum for everyone else.
Oh, it does. This talent vacuum is going to act as a massive consolidation event. Think about the mid-tier AI startups right now.
The ones stuck in the middle.
Yeah. They don't have the sheer gravity of a top-tier lab to attract those bleeding-edge researchers, but they also don't have the massive war chests of the major cloud platforms to hire an army of infrastructure engineers. When a hiring surge like this happens, they lose people they just can't replace.
So the winner is whoever gets the right people to work together before their rivals do, which requires that $7.4 billion. But that money isn't just for paying out tech salaries, right?
Yeah.
In a volatile market, having that much cash on hand buys you something much more crucial.
Endurance and control.
What do you mean by endurance? Like outlasting the competition?
Strategic endurance, yeah. That capital pays for uncertain computing costs, failed experiments, and infrastructure that might not generate cash for years. And importantly, it preserves founder control rather than ceding power to venture capitalists who demand immediate returns.
Which brings up a massive paradox to me, because they have to move incredibly fast to keep up with the cutting edge, but they're also trying to land massive enterprise clients.
Yeah, it's a really tough balancing act.
Right, because that means guaranteeing bulletproof reliability for a national scale platform. How on earth do you balance open experimentation with
It is incredibly difficult, and it brings us to one of the biggest dilemmas they face, the trap of the open model.
Let's clarify what an open model actually is before we get into the trap. Does that just mean anyone can use the website for free? Or is it deeper?
Oh, it's much deeper. An open model means the creators actually publish the underlying weights, like the fundamental math and connections that make the AI work.
So you can just download it.
Exactly. You can download the actual brain of the AI and run it on your own servers, completely independently of the company that made it. So if you run a manufacturing company, you can customize it privately on your internal data without sending anything back to the creator.
But wait, if you give away the blueprint for your hyper-efficient model, how do you pay back a $7.4 billion investment? Aren't they doing all the heavy lifting just to let cloud providers scoop up the profits?
That is the central risk of their entire strategy. When you release the weights for free, computation just becomes a commodity.
Because anyone with a server can host it.
Right. The cloud providers, the companies that actually own the data centers, they can just host your open model and charge customers for the electricity and processing power required to run it.
So the cloud provider captures all the margin, leaving the model creator essentially famous but broke.
Exactly. Releasing an open model basically triggers a massive price war.
Which helps the customer, sure, but it sounds like financial suicide for the creator.
Well, for the providers, a price war forces them to desperately prove what their premium actually buys. DeepSeek has to decide where they actually capture value.
Like, are they just a model maker giving away blueprints? Or are they a developer platform?
Right, or are they aiming to be an enterprise software provider? And depending on what they choose, it actually changes the shape of the global internet.
Because this leads to the fragmentation of AI, right? We've been talking about AI as if it's going to be this one universal layer covering the globe seamlessly.
Yeah, but a model isn't just abstract code. It's code optimized for a physical world. It depends on specific processors, memory, compilers, and data centers.
So if these open models start being optimized around different local chip architectures or regional regulations,
We won't get one single global AI layer. We get competing, separate global stacks.
which brings us to a massive roadblock. Because even if they solve the puzzle of how to make money off an open model, there is an ultimate bottleneck that billions of dollars cannot magically solve overnight.
The physical realities of hardware scarcity.
Exactly. They are on a collision course with physics and geopolitics.
Because AI is heavy industry. You
Yeah.
cannot just buy a reliable computing cluster the way you lease office space.
Right. You need specialized memory, immense cooling, power, and the most advanced chips in the world.
And right now, those advanced chips are bottlenecked by highly concentrated supply chains and strict export restrictions.
So it's like trying to build a global airline when you aren't even guaranteed access to the basic building blocks. How does a company scale if they are restricted from buying the best engines?
Well, there is a powerful contrarian insight here. The immediate assumption is that restrictions on advanced chip access simply slow a company down. And they certainly do.
Right. Yeah.
But they also create a profoundly intense incentive. If you cannot rely on having the absolute best, most abundant hardware, you are forced to become fundamentally better at software efficiency.
Scarcity is a roadmap.
Yes, exactly.
Can you give me an example of how that software efficiency actually works under the hood? Like, how do you overcome a lack of processing power?
Sure. One common method is called quantization. It's essentially teaching the AI to do the exact same complex math using fewer decimals.
Oh, interesting.
Yeah. If a standard AI uses ultra-precise numbers that eat up a huge amount of memory, a constrained engineering team figures out how to round those numbers off.
So it uses a fraction of the processing power, but still gives a quality answer.
Exactly. Scarcity forces you to optimize your models for alternative, less powerful hardware. Scarcity actually becomes your roadmap.
That is such a wild irony. By being cut off from the easy path, the brute force path of just buying the biggest processors on the market, it inadvertently forges a much more resilient engineering culture.
They have to squeeze every single ounce of performance out of constrained compute. And learning to operate efficiently under constraint matters immensely.
Because eventually the brute force method runs out of juice.
Right. Even in places with abundant access to chips, the sheer energy and infrastructure costs become unsustainable. An engineering culture built on constraint might ultimately outcompete a culture built on excess.
So the ultimate constraint isn't just funding. It's the ability to assemble and operate a physical computing system under uncertain conditions. Now, if you are a business owner or a developer listening to this today, you might be wondering which timeline we're actually heading into. Let's lay out the two distinct possibilities here.
Okay, so in the best case scenario, the bull case, DeepSeek successfully uses this capital to recruit that exceptional airline crew. They improve efficiency, build a trusted ecosystem, and become a true platform.
Which lowers the cost of intelligence for businesses globally.
Exactly. They expand access beyond just the massive corporations that can afford infinite cloud spending, and they break the monopoly of a single technology stack.
The biggest winner there is every business that suddenly gains massive choice and leverage. But of course, there's the darker scenario.
The bear case. The risk is that they expand too fast. Their physical infrastructure costs rise significantly faster than their revenue.
And the larger the organization gets, the more it loses that razor-sharp focus that made it distinctive in the first place. The scrappy startup just becomes a bloated bureaucracy.
Right. And those open models generate massive attention, but absolutely no durable monetization. The established platforms with deep cloud capacity just scoop up the open models, run them on their own hardware, and capture all the value.
Leaving the world with fragmented, siloed AI infrastructure where data can't easily cross borders.
Exactly.
So if you're watching this space, what are the key metrics to actually pay attention to?
First, watch the hiring mix. If a top-tier lab is only hiring researchers, they are still just building engines. But if you see them hiring infrastructure, product security, and operations experts, that points toward a true platform strategy.
What about the open models themselves?
That's the second thing. Watch whether the massive interest in open models actually turns into paid enterprise adoption.
Because getting a high score on a math test is great. But a customer actually paying for support and reliability is what keeps the lights on.
Exactly. And finally, watch the hardware ecosystem. Are the model, the cloud tools, and the physical infrastructure becoming efficient together?
So tracking the actual cost per useful task is critical. The future won't be decided by who has the largest, most theoretically brilliant model. It'll be decided by who can deliver reliable intelligence at a cost that a normal business can actually sustain day in and day out.
The moment intelligence becomes infrastructure, the race is no longer only about who can think, it is about who can build.
I love that. The early AI race rewarded the best demo, the smartest parlor trick. But the next race rewards the strongest, most dependable system. Which leaves us with a final thought for you to mull over today. We started by talking about how AI is moving from a magic trick to a corporate utility. If this best-case scenario plays out and intelligence truly becomes just another invisible layer of industrial infrastructure, as cheap and dependable as electricity, how does that change the fundamental value of the work you do every day?
Right. When the heavy lifting of thinking is just a utility you plug into, what is the uniquely human premium you bring to the table?
Exactly. It becomes the difference between generating a highly efficient answer and knowing which question actually matters in the first place. Until next time, keep looking past the headlines.